It is now 6 o'clock, and we can go ahead and get started. First of all, thank you so much for joining us today at Woven Planet for our first ever C++ Meetup. We're really excited to have you and appreciate you coming all the way to our office. We are really lucky today. We have 3 amazing members of the C++ community joining us as panelists today for a discussion. They have come from all over the world to join us, and we really appreciate you guys' trip. Thank you. So for everyone joining us tonight, this is really your opportunity. We want to create a sense of a C++ community in Tokyo. Some of the best C++ developers in the world come from here, and it's really great to see everyone together. This is a chance for you to ask your questions, interact with our panelists, and hopefully get some awesome answers to whatever you are interested in or concerned about with regards to C++. I will start off with a couple questions we have selected from the list and ask people to come up. But remember, this is supposed to be an open discussion, so we really urge you to come up. We have our mics right in the middle of the room, and we hope that we can get a good discussion going. それで日本語しか話さないメンバーも結構いると思うんですけれども、日本語のサポートは完全に提供してますので、質問を聞くときは英語でも日本語でもどちらでも構いませんので、ぜひ遠慮なく何でも聞いてください。So going from there, I'd like to introduce our panelists. We can start closest to me and just go down and we can learn a little bit about them. Thank you.
Thanks, Nick. So I'm Bastien. I'm Chief Architect at Woven Planet, and I'm also the chair of the C++ Language Evolution Group.
I am Jason Turner, and I find it very difficult to actually say what I do. I have many different hats that I wear, I guess. YouTuber, author, trainer, do C++ contracting, open source. Pretty much everything about my career has been C++ focused for 20 years now, but I just do whatever comes across. And if you don't mind, I do want to congratulate you on getting this meetup started today here, because the C++ community has been important to me for a long time, and I love to see more community development around the world.
And I'm Christopher DeBella. I work for Google on the Chrome OS toolchain team, which means that I'm mostly looking at LLVM-related things and how they can be integrated into Chrome OS to make the toolchain experience, to make the developer experience better. That's at the moment focusing on improving code health and on improving diagnostics, so that way C++ developers can have better error messages.
You said we're from around the world. JF, you live here.
Yep.
I'm in Denver, Colorado in the US.
And I'm in California.
Okay.
All right, thank you very much. So let's just jump right into it. We've just picked a couple questions to kick things off, break the ice a little bit, and then obviously right in the middle, please come up whenever you feel and ask any questions you have. Let me get going with a question from the Woven Planet. There was a question about C++ modules that we thought was really exciting. Would you mind coming up to the microphones and sharing your question with us?
質問を何を書いたのかちょっと忘れてしまったんですがそうか、だから処理系ごとに C++20 からモジュールという機能が新しく入りましたけれども、あれが処理系ごとに結構実装がまちまちで、例えばなんだろうな、テンプレートの特殊化が BMI に含まれるか含まれないかみたいな話が実装ごとにまちまちというのがあって、現状だとなんかそのコンパイラの間で過半性を保った状態でモジュールを使うっていうのが難しいという状況があると考えていて、その辺が今後企画の方からはなんか改善されるんだろうかみたいな話を書きました。はい。
Yeah, I guess I'll take this one. So modules in C++ have a fairly long history. They started more than 10 years ago and diverged in terms of what people thought they should do and how to do it. Right? It's trying to resolve the problem of textual inclusion that we have with headers. and the problem of exposing, macros and a lot of other things that you don't necessarily want to expose. However, it's difficult to embrace, legacy code while giving developers a path forward. And so the current design of module tries to bridge that gap by having a recommended use of module and then a way to move forward in adopting them incrementally by still being able to expose certain things. And some of those things aren't implemented the same way in different compilers, right? So the standard says you should expose things this way if you use export here where the template exposes that way. But there's a lot of things that aren't exposed particularly well or that are ill-specified, and so compilers did different things. For C++ 23, we're trying to address a variety of those. For example, what does it mean to export a template deduction guide or something like that? That's a gap that's not specified today. And there's also gaps in how C language features are exposed. So for example, when you do static inline in C, that's very common. It's technically in C++ an ODR violation, so one definition rule violation for certain things, but it's very, very common in C headers. And so for example, if you include time.h, the time function in C, is usually static inline, and in modules, those aren't re-exported for a variety of reasons. And so, and it actually prevents you from compiling because you're not supposed to do that. And so that's the type of gap that we're working to address in C++ 23 to specify where compilers have diverged. And a lot of divergence is ill specification in the standard, and developers for the compilers choose what they've encountered as pain points for developers that they think is the right solution. So there's a process going forward, and I think it's going to get better in C++ 23.
Can I add on to that? This is not from a standardization perspective, but rather from a toolchain perspective. While you're waiting for modules to be fully fleshed out as and address the points that you've articulated, that JF has articulated. If you're using Clang, Clang has an extension that allows you to take your existing code, not change it at all, and add what's called a module map file that then instructs Clang on how your headers should behave as if they were modules, and they will only export things if you put them in the public-facing interface in this particular map that explains how the compiler should be understanding these headers. And it does significantly improve your build times and export only certain symbols. So, for example, if you were to include the algorithm header, and I don't remember if it exports the iterator header, but it will need to import that. If you include the algorithm header, it won't let you use the stuff from iterators unless you also explicitly include iterators, or it's explicitly said in the module map, hey, we're exporting this, the user is allowed to indirectly take it. And so that will help bridge you over to get the benefits of modules now with the legacy syntax, and then once the syntax is once C++ 23 has fixed the problems from C++ 20, you can make that migration. But you can do that today in modern versions of Clang.
I'm curious if you can actually, or either one of you, speak to the conformance today of Clang or GCC. Do they implement C++ 20 modules as specified today? Do you know?
Clang doesn't fully do everything. It takes bits, because the Clang header modules that I was talking about, it was something that informed C++ 20 modules quite significantly. I believe the implementers are using some of that, but it is still a different thing, and the developers need to put a lot of work in to get that there. They're not all the way there yet.
Okay.
Yeah, and I think Visual Studio probably has the most conforming implementation, because the primary author of the current C++ 20 modules works on Visual Studio.
Right.
The GCC one, I think, is fairly good, but the Clang one, as Chris was saying, it has existed for 12 years or something, right? So modules have been in the works for, 20 years for C++. The Clang one has existed for a long time, but the the standard has diverged from it, and it has a lot of useful features within Clang, but it's not all exactly, if you use Clang module versus C++20 module, it's not all exactly up to date, I think.
Right.
But it's being worked on as well, so it's going to get there.
I haven't been following that closely, so I was curious.
Yeah, thank you.
Thank you very much. Okay, let me just queue up one more, and then I would like to ask the audience to start thinking about what you'd like to ask and step up and ask in the podium in the middle as well. I know it's quite nerve-wracking, but we are actually quite nice, so it should be okay. You had a really interesting question about memory safety in C++. Are you here with us tonight? Yeah, would you mind coming up into the middle and sharing your question? Thank you.
Yes, so I asked the question about, well, maybe from a standardization perspective, but we have seen a lot of evolution around C++ regarding memory safety with Rust, Carbon, many different languages. And I was wondering kind of what is the path forward for C++? How do we integrate those ideas from those languages into the current existing C++? And basically, is it even possible to do it?
Thank you.
Wow, both of you are looking at me right now.
I was looking at you because JF was looking at you. I was looking at JF first.
I actually have given some thought to this recently. And now, to be clear, I'm not involved with the standardization of C++ at all. So I don't have any, I've never written a paper for the standard. I've never implemented a compiler. I'm looking at people here who have done these things. But to get Rust level guaranteed borrow checker kind of memory safety, I don't really think that's feasible in C++. It would be a redesign of the language in many ways. But on the other hand, if we write code in a way that follows modern best practices, we avoid using pointers where it makes sense to, we prefer stack objects, we don't try to do manual management of resources. In my code in the last 10 years or so, it's extremely rare for me to actually have a memory-related bug in my code. And if you take advantage of sanitizers and compile your code with address sanitizer, undefined behavior sanitizer, and run all of your tests through there, then we can get another layer of safety. Now, that assumes that the tests that you're running actually have full code coverage. So just out of curiosity, who currently has 100% code coverage in their test? What, no one? No one has 100%? I'm so confused, right? No, of course not. Oh, I was just convincing you to raise your hands. So then to get the third layer of protection using our tooling, if we can use fuzzing to generate tests for us that are tested with the address sanitizer, then we catch those corner cases that we didn't cover when we just used good, sane best practices with memory, with code around memory. So I feel like with a multi-layered approach, with the tools we have today, we can get very, very close to languages that are safe by design. But I don't think we'll ever get 100% of the way there. I think it's a new language if we try to.
Yeah, and I think what's particularly tricky is, at least from the committee's perspective, balancing older code that already exists, right? Like, so C++23 code, older code, to C++26 code if you want to do that upgrade, right? If the committee wants to be very careful in adding features, adding performance, allowing you to have better safety and security without telling everyone, drop whatever you had before. And that's a very tricky balance to create. And in some cases, it's not clear what we ought to be doing. So the borrow checker, for example, a lot of what it does can be had through powerful static analysis. Right. And then when that falls down, you go to dynamic analysis in some cases. That's hard to do in C++, and for a while the committee maybe thought, maybe we can do it through static analysis. Maybe it's sufficient. And so a variety of people have tried different approaches. There's the core guidelines, for example, that give you standards on how to address some of these issues. There's a variety of other standards in different industries, such as MISRA, that we use, for example, in automotive to say, do these things, don't do those things. And all of them give you certain things while trading off a lot of things as well. MISRA is hard to use well, the current version, because it's fairly old and doesn't address all the things that matter. It mixes style guide versus best practices. Same thing with the core guidelines. Sometimes they get you to do things that you shouldn't really necessarily do. And so the joke we always have is that there's a good subset within C++. If you just stick to that, then everything's fine. But nobody agrees what that good subset is. And it really depends on what your application style is. And so I think C++ itself will try to cater to a very wide audience and can do a few things to help with safety and security, but a lot of it also comes through tooling, just because of how the language was built, right? It was built 40 years ago when the technology in computer science to create languages was significantly different. Rust was created less than 20 years ago with some nice advances in how to create languages that have particular safety properties by default. But for example, if you want to eliminate data races, like Rust tries to do with its sharing model, you can do that today in C++. Right? You don't need ASAN to prevent you from having data races. You need to have libraries that you might build yourself that enforce the same sharing rules that you would have in Rust.
That's a good point.
That's something that you can choose to do, but again, your code won't magically be data race safe if you do that. And TSAN can help you get there if you have existing code. But again, tools aren't used that much within the industries. I think we have a yearly survey for C++ developers that the foundation sends out, and very few developers use those sanitizers and static analyzers and other things. And so the hard reality is if we have gains that we can put in that break very little code or no code, but give you extra safety, we should do it. And so when we were, 2 weeks ago, the C++ Standards Committee got together for the first time in 2 years. We were doing virtual telecons before, and we had an evening session that I ran on, what does the future of C++ look like? Trying to see different people from the committee, how they would come together to solve some of those issues. And I think safety was really top of mind, safety and security. And so last week I put out a proposal, I think it's called P2723, about initialization of stack variables, where it's one thing that we can do to solve roughly 10% of security issues with effectively no performance hit. Right? Even doing that well is quite tricky because you need to change how the language works and synchronize across vendors and other things. And so I think there's no one solution to how we're going to get safety and security. And when we say safety, we mostly mean security in the C++ community. When we say safety in automotive, we mean a completely different thing. None of these address correctness. Right? There's a variety of tools that you can use in languages like Rust to, at a type system level, give you correctness. You can do the same thing in template programming, but I don't think you want to. So it's pretty tricky, and I think we'll need a variety of solutions to address all these issues.
I don't really have anything else that I can add to this brilliant, well-rounded answer, but to kind of do something similar to what Jason did, can I get a show of hands? How many of you are familiar with sanitizers?
Oh, right. Should I raise my hand too?
You can raise your hand. JF would have to as well. Okay. So for those of you who actually, of those of you who had your hands raised, how many of you use sanitizers today? Substantially fewer hands. Okay. For those of you who know what sanitizers are and have the opportunity to turn them on, please do turn them on. They will catch a lot of problems initially, and you will be very grateful for that. For those of you who
Oh, I was just going to say, if it doesn't catch any issues initially, then you probably need to run some fuzz test or something else because your test coverage is probably not sufficient.
And now that Jason has mentioned fuzz testing, can we get another show of hands? How many of you know what fuzz testing is? Okay, that's actually a pretty good number. JF, did you raise your hand this time?
I did.
Okay, cool.
I did.
Just checking. Sanitizers are a form of there's something that the compiler goes and adds additional code to your codes, so that way when you do things like doing dynamic memory allocations or doing things with memory with pointers, it will follow certain code paths that will then allow the runtime to trap to catch bad code and make sure that you are doing things like not accessing invalid memory regions or trying to do something like delete the same bit of memory twice. It checks that you do things like does undefined behavior sanitizer do things like checking for division by 0?
Yeah.
That sort of stuff. Okay.
It checks for most. It's largely integer related undefined behavior.
Okay, cool. So
I'm not checking my email, just for the record.
It's all good. It's all good. I understand. Someone at Google once said that the sanitizers basically take undefined behavior, which is essentially an interpretation of things that can happen, and it gives it very well-defined, meaningful behavior. And the meaningful behavior is basically the runtime will say, hey, you did something wrong, I'm going to stop execution, you need to go and fix this. But it will very much improve your lives. There's many sanitizers. The most common four, I think, are address sanitizer, undefined behavior sanitizer, thread sanitizer, which checks for threaded things, and then memory sanitizer, which checks for uninitialized variable reads, I believe. The catch for that one is you need to rebuild your entire program from the standard library up, and so you need to own the entire toolchain to do that.
And not all of those are compatible with each other.
Right. Thank you for pointing that out. I did forget that.
So you might have to have multiple different builds of your test suite that each run the combination of sanitizers that can't run together.
Yeah. Thank you.
Awesome. Thank you so much. That was a really great question and a really interesting. Yeah.
I'm not done yet.
Oh, sorry. Don't let me cut you off.
Like I said, I was not checking my email here. I was double checking something. I said that it's difficult to pin down what I do. I have a YouTube channel. It's called C++ Weekly. On this topic, oh no, man down. I have been, I've put myself on a mission to make sure that everyone is using all the tools that they can and making sure everyone knows about the tools. So starting with episode 347 and going through, that was a few weeks ago, episode at least 354, 56. It's like 9 episodes in a row that are all tooling, why you need to be using it. I kind of am repeating myself, but with different clickbait titles, because I really want people paying attention to this. It's the only way I feel like we're going to move forward, practically speaking. Even if C++ 29 solves all of these problems, when will it be that Misra adopts C++ 29?
Any day now.
Right,
Day.
exactly. We have to solve the problem with the tools that we have today.
Yeah, so I really recommend watching Jason's channel, particularly those videos. They're fairly short, and they really explain very well what the tools are, how to use them, and why you want them. So.
And I have several more coming up. So it's at least 3 more weeks from today of this kind of thing.
All right, thank you.
Awesome. Sorry for cutting you off. That was awesome. Thank you very much.
No, sorry for interrupting you for cutting me off.
We can go all night. We have a question from an audience member. Thank you for your patience.
It's all good. Would you believe I have a question about the latest C++ Weekly?
Sorry,
No,
can you
I
tell
would
us
not believe that.
Oh, great. Thank
I'm
you.
C++ programmer enthusiast. I do C++ half the time at my job, I guess.
Yeah.
Which one? I'm sorry. Do you mean the one that was just released yesterday, or
Yes, and I'll try to describe it because it does involve some code, but it's not. I don't think it's too difficult to describe.
This is your 5-step plan for deeper C++ knowledge, right?
Exactly.
Okay, just making sure. Okay.
Yes. So in that episode, you had set up a toy example of a class called Lifetime,
Yes.
which I think a lot of us have written just for our own edification at some point, which is like we've got the rule of 5 and all of those copy move constructors, default constructors have print statements in them that says, hey,
Right.
I'm being constructed, hey, I'm being copied, I'm being moved, I'm being destroyed. Right. So after you've written that class, you had a series of functions F1, F2, F3, I believe, where this was just to prove that if you have F3 returning F2,
Yes.
execution, F2 returning F1, and then F1 just returns an empty lifetime.
Right.
The point was to prove that only one object gets created and only one object gets destroyed during this process.
Yes.
And a lot of times when I'm watching your channel and some other channels, like tutorial type channels, if I kind of see where the presenter is trying to go, I think, and I'll kind of just like hold the answer in my head and like wait for them to say it, sort of. And in this case, I was thinking he's going to say copy elision. It's copy elision. Like the compiler knows that it can emit all those copies, so it just went to the end because the standard explicitly says you're allowed to do that.
Yes.
But you didn't say copy elision, and I was kind of left wondering, I wonder, like, is it something different? Is it not actually copy elision?
Well, technically in C++ 11, it would be move elision because they would be implicit moves. But if we want to go back before move existed and before the standard explicitly had those words in it, if I have my history right, one of these two might be able to correct me, we would have just called it return value optimization. But I don't like either of those. And now you're going to make me stand up and go into teacher mode, as I've been doing teaching for the last 2 days here at Woven Planet. The problem, the specific issue is, you think you created an object right here and returned it from your function. But because of our calling conventions, we don't actually get that. If you have a function that returns a parameter, there's a hidden first parameter to that function that is the address that is going to be the ultimate location of that object. So if I create an object here on the stack and say, or a type, whatever, Jason's type equals whatever, and I'm calling Chris's function so many levels deep, and I'm creating an object over here, that object always lived right here. Its space, its storage with the proper alignment was created at this memory location. A pointer was passed forward, however many levels deep it took, and the object was conceptually initialized 5 functions deep. But it always was here. So I don't like the words move elision, copy elision, return value optimization, because it's not an optimization in most cases. It's the nature of our calling conventions. So that's one reason I didn't use the word there. Now, if I was teaching a class, like I have been the last 2 days, I explicitly say all the things that I just said just now. Does that answer your question?
Yes. Well, so if you were to call it something other than the things that are, I guess, misnomers, you would say it's some quirk of the calling convention.
In a way, yes. If you want to actually call out the standard ease on this case, the standard says, I just covered this yesterday. Ooh, there's a blue screen now. That the compiler treats the source object and the destination object as 2 ways of referring to the same object. And that's what I like to drill into my students, is that the object never moved. It was always right here. And the standard allows that. It says it's 2 ways of referring to the same object, or multiple ways, depending on how many levels deep this goes.
Thanks. That does answer my question. It seems like we had the same, well, attracts my understanding of what's going on with the compiler and the calling convention. It's just that calling it different things, I guess.
Yeah. And I have a very old episode now. It's called The Optimal Way to Return from a Function. I believe that's correct. And I go back to compilers from 1998 before like any of this wording was in the standard, and that's just what they did. It's always been there, basically. Now, when you get yourself into trouble is if you have two different potential objects that might be returned depending on the pathway. Now, the compiler can't decide that one of them should be the same way to referring to the destination object. And then in that case, you're going to see a move. I didn't demonstrate that in that code. But if you go ahead and add some branches, play with it again, and see, does one or the other get elided? And forget the word elided. Does one of them become a reference to the destination object or not? Or do you get a move in both branches? That's when it gets exciting.
Understood. I'll try that.
All right.
Thank you.
And I
Thank
think in the language overall, we tend to have a lot of named things, right? Like acronyms, we love them, CRTP and stuff.
Yeah.
And I think it makes it hard to learn the language and use it well. And some of them, like this one in particular, I think is more of a historical, compilers used to do it, and then the standard was put in place with some holes where you technically weren't allowed to do it. So some compilers just diverged and said, look, I want to do it. It doesn't make sense to copy stuff, or I would need to have move semantics to be able to do it. So a lot of work was put in to realize what ought to have been from the beginning. And that history accrued as, oh, well, you have an RVO and you have this thing and that thing. And it's a bit unfortunate that they still stick around as we've eliminated the need for those acronyms. Now, maybe CRTP will go away one day. I don't know, but the other types of things, I think we should try to de-emphasize and instead teach what you want to have, as Jason is trying to do, rather than needing to know the whole history of how things came to be able to disentangle all the acronyms.
I still think there's some value to having a name for whatever it is, even if we have to change the name, because otherwise you're stuck saying, oh, it's just this is how it is, and it's some quirk of some larger thing of how C++ works when you compile it.
Then, I guess you're going to have to use move elision in that case.
Yeah.
Because if we talk about C++ 17 having guaranteed move elision in the case that you return construct an object in the return statement, then that's what the phrases you need to use. Do you agree? You too? I've spent a lot of time talking.
I don't really have an opinion on this one.
What's that?
You done good.
Okay. Use move elision if you want to call it something. But now you know the full history of why I don't like using that word.
Thanks.
Thank you so much for your question. That was great.
I work on general programming languages stuff, mostly security. And there's something that caught my ear that you said earlier when we were talking about Rust and these other languages that are newer and that get to use some new stuff that didn't exist back then. It sounds like what this gets to is that, I don't really know how to phrase it, but it sounds like C++ might never be able to benefit from some of the advances that have been made in the programming language field that newer languages are able to benefit from. And I'm sort of wondering if that informs about the future of C++. Is there a path forward to using some of these new technologies ever? Or is it like, is C++ forever stuck on, the 90s and doing its best to catch up?
80s, late 70s.
Yeah, for the panel members, there were a number of questions actually about some of the new languages versus the pros of C++. I think a lot of people would love to hear your thoughts on that as well.
Yeah, I think a lot of those advances can be learned from, right? That's why right now a lot of people are exploring different ways to do something like C++. Like Rust has been around for a while. It has a lot of interesting things that it does, but things like Carbon or Val or CPP Front are trying to slice the same problem space with different trade-offs. So for example, CPP Front is much more focused on backwards compatibility than the other approaches might be. Val is more insightful in terms of if you really go far with value semantics, what do you get out of it? And Carbon is doing a bit of a mixed approach, I think, in terms of what it tries to do there, where you can have automated tooling that helps you do some of the migration so that you don't have this legacy code, but also takes assumptions into account of I can manipulate all of this code in particular ways, and different types of users will have different things that they like about each of those. But fundamentally, I think there's interesting research in these areas being done, and I think some of it will be definitely applicable to C++. Now, whether it's something that we can just put into the language and everyone can start using it, I'm not sure. Right? Something like coroutines or pattern matching or whatever else, sure, we can add those things. Right? That's doable. But something like the borrow checker is a frequent thing that we talk about. It would require a good amount of transformation of how C++ fundamentally works to be able to do it. And if we don't talk about just safety, but ease of programming, things like concepts were meant to make the accident of templates have fewer sharp edges. Right? Templates.
The accident of templates.
So templates were designed to be, like you pass in a value and then it instantiates a version of it with that value. It was not designed to be Turing complete.
What?
It was accidentally Turing complete. Sphinx was not designed to be a thing. It's just something that we found. There's a variety of things in C++ that were, let's do Bob Ross here, happy accidents.
Okay. But emergent behavior.
Yeah, emergent behavior.
Penicillin.
But not like, if you've used templates a lot and you go back to your code a year later, you look and you're like, wow, that was a mistake if I've done too much of it, right? And concepts are meant to try to reduce that accidentality, make it easier to write, easier to read and maintain. Whether they succeed or not, we'll see, right? But I think there's a variety of things that we can do to make the language easier to use. It's the same thing with things like, constexpr. Constexpr has emergent behavior that is also accidentally Turing complete. And then you take it further and makes the language easier to use in many ways. And Jason's used that to great lengths in his Amiga keynote at CPP
Commodore,
a few years ago.
64.
Commodore,
Yeah.
sorry.
Actually, that's a surprising false memory that almost everyone has. I didn't use constexpr in that code.
I thought you did.
Nope.
Well, I'm sorry to have insulted you with the burden of constexpr.
No, it's fine.
Constexpr, all the things that there was a separate one, yeah?
Yes.
Constexpr, all the things is very separate, but the Commodore 64 one from CVPCon 2007.
16, that was my first one.
17. No, it wasn't 16.
It was.
Was
it was
it?
after Dan Sachs' argument one. That was 16.
Oh, well, I'm older than I thought then. Yeah, no, I actually just, I don't use constexpr in that code because at that point, I actually still had a bad opinion of constexpr. I've changed my opinion an awful lot since then.
Yeah, so I think some of the tools that you have in other languages will be usable in C++ eventually. And the difficulty will be whether when we make changes, there's some necessary amount of code change to migrate from one standard version to the other, and how we make that possible. By and large, tooling has not been used to do that. And if you've upgraded from C++ 03 to C++ 11, you've probably gone around and added spaces after a bunch of things because like the way strings work change with user-defined literals, for example. And that type of very simple breakage that's easy to automate, we've not historically done it. And I think we might get better at doing this and provide tooling to then allow you to have better language features that are easy to use. But But in other cases, it'll be a mix of, do you want to have some amount of real specified static analysis mixed with dynamic analysis to give you properties that aren't readily expressible in C++ today. And then at some point you say, well, if we design a language from scratch, we could have done it better, but this is about as good as it gets, and it's within 10% of the best, and so it'll be good enough. Right, so I think it's really tricky to figure out how to have these pragmatic solutions to complicated problems. And in some cases, if you have a new code base and you can use a new programming language, that's cool. I think you should. Like it's worth exploring and seeing what other things look like. C++ is not a religion in itself, right? It's just a tool.
Well, for some people it is, I think.
But it's a tool, right? So I use tools in different ways, right? So I think it's worth trying that as well.
I'm going to ask a question that might seem a little silly, but is this going to end up on YouTube?
Yes.
Okay. I have to phrase my answer slightly differently than I might have otherwise. I just kind of want to add to this conversation a little bit, because you asked, like, if C++ will ever be able to get some of these cool toys, basically. Is that a fair way to phrase that?
I think you could say that, yeah.
Okay. I have heard some people discussing who are very familiar with Rust, use Rust regularly, and you commented that Rust is on the order of 20 years old. Is that what you said? 10 years old?
Something like that, yeah.
Something like that. It's been around for a little while. That are like, well, I wonder what it would look like if we tried to make a modern memory-safe programming language today. Like Rust users asking that question, right? So I think we're kind of always, in a way, going to be asking that question. Because as soon as a language becomes popular enough that people are using it, it's old. I don't know. Maybe I'm overthinking it.
Well, I think computer science is a young field, right? So saying something was done 20 years ago that's old in terms of the age of this field. And it's a very immature field when you compare it to mechanical, civil, electrical engineering. And so I think that's part of it too, of the things that we've learned collectively. Like I used to work with someone who had a PhD in parsing. Like for us nowadays, it's like parsing, you just parse, But it was a very difficult field at the time. And knowing someone who has a field in something that seems so basic now is pretty mind-blowing.
Well, and some of these questions that we ask, like how do we avoid undefined behavior, or memory accesses that are out of scope, or, memory checker kind of things, like didn't Ada actually solve all of these problems in the 70s already? And now we're treating them like they're new problems. They're not.
Yep.
It's old and new at the same time.
Indeed. I actually want to go back to the Rust thing that you were talking about just a moment ago.
Okay.
You mentioned that once you reach a certain mass of people using the language, it gets it suddenly becomes old, and that, sure, I agree with that. But it also speaks to the point of, as you get more users adopting something, you are going to find more problems with it. Mm-hmm. And so while from a young Rust perspective to a bunch of C++ programmers who are kind of disgruntled with the memory model that we have, looking at Rust and going, this is nice and shiny, but Rust may have its own problems that just haven't been surfaced because there haven't been enough people using Rust. Now that there's lots of code bases that have started to adopt Rust quite substantially, people can start to see what those are. And I think that's why these people that you've alluded to have started asking that question, because it is a moving target. And I don't expect that we'll ever, in computer science, ever attain that goal of reaching where civil engineering is, because it is just such a fast-paced field. Maybe the civil engineers, actually don't know how old civil engineering is, but I'm going to guess at least 2,000 years old, probably more. Maybe they felt the same way, and I'm just being naive.
Thank you. We have just about 5 minutes left.
Oh, no, we talked too long. Sorry.
No, just fine. And I think we can get to one last question and then have a quick wrap-up and jump into a meet and greet.
Embedded developer. You have mentioned
Sorry, when you mean embedded, do you mean like 8-bit microcontrollers, or do you mean like ARM running full Linux?
ARM running full Linux for the most part.
That's a computer.
Yeah, that's I guess. Yeah.
Sorry.
Yeah, no worries. Yeah, you mentioned earlier the maturity of the field, training, given the vast complexity of C++ and it's steadily evolving, and also considering the vast spectrum of developers and experience. Do you have a piece of advice what you would give somebody to bring a team to some kind of baseline proficiency? I guess you could front load everything. These are the rules you have to follow, or we adopt here, lead by example. Anything else you would like to add to this?
Yeah, it's tricky. So of course, teaching is a good way to help, level everyone to the same level of understanding. But I think a good onboarding process for teams is useful, as well as a lot of automation, right? Mm-hmm. I think particularly in fields like automotive, we want to have fairly strict rules that folks follow, but that they know how to follow well. So having a handful of experts that help bring everyone up, I think, is the best way to get there. Otherwise, like if there's no automation and people just do what they think is right, you end up with a mess, and it's hard to get out of it, right? So teaching each other is really helpful, and then to go faster than even just watching Jason's videos is a good way to get started in a lot of ways. You don't even have to pay him to get a lot of teaching.
You are welcome to pay me for teaching. That is definitely a thing to do.
Another way you can not undercut Jason's business model here, but if you want to get into the community a bit more and really get to kind of push your limits, get your colleagues to push their limits, interacting with the hash include C++ Discord is a great way of getting involved with the community, because there's a lot of great people there who are very knowledgeable on the subjects that you'll be asking about. And if people don't have don't know something, then a few hours will go by and someone will pop up and have just randomly know the answer to it and tag you in the answer. So that's another good way of getting interacting and getting knowledge. But I think JF's point about tooling is, and automation is the most important thing, on par with good training and getting domain experts.
No, it really is better than good training. I have to, yeah. If you can automate as much of the process as possible, that reduces the load on everyone. Training new people is much easier because they try to, put an obvious null dereference in their code, and cling tidy stops them. You got errors, warnings as errors, hard stop, sanitizers in all of your tests, like we've already been talking about. Automate absolutely everything. Cling format on commits so no one has to argue about syntax, right? Everything you can automate. You have that, and I have had the opportunity to go into companies that have all of that set up, and the training experience is completely different, because we don't have to talk about half of this stuff. Now we talk about oh, you want to really understand what the compiler is doing? Let's talk about what the compiler is doing here. And it gets changes the level of conversation entirely once you get the mundane stuff automated. It's very important.
Yeah, but I think Chris makes a good point. There's compared to when it was like Complang C++ or whatever, there's a variety of really interesting communities that exist today that didn't exist 20 years ago or something.
Yeah, for sure.
That there are great resources to ask pretty basic questions and get support and answers and things like that. And the learning resources online are also quite good. Books are still useful.
Books.
Do
people write books still?
You wrote a book once, right? So,
one book and 7 puzzle books. actually right now.
And you know, there's a variety of things, right? So even though Dr. Dobbs is no longer a thing to learn C++, there's a lot of other kind of useful resources, kind of the Discord, the #include Discord is a lot of interesting support areas, different channels that have different types of topics or level of familiarity. So, yeah, and I think often also going to conferences is a way that people learn a lot. I know certainly a lot of folks I've interacted with have learned a tremendous amount inside of conferences, and there's a lot of them right now that produce great content. Just put it online for free as well. So you know, there's a lot to choose from and where to go to level up different types of people, different fields. Yeah.
Thank you very much. I'm sorry, we are out of time, I know. And we need to move on so we can go to the meet and greet. Thank you very much. I really appreciate it. Questions were fantastic from everybody. I love it. Jeff, would you mind just... Jason, do you really...
You need to volunteer to speak at this meetup in the future.
Yeah.
There.
That's another thing that we can
I got
do.
my word in.
That was awesome. Thank you. Jeff, would you like to read us out a bit? I know you had something you wanted to say about the community.
Yeah, so thanks everyone for coming. This is the first time we do a C++ meetup here, and we hope to kind of start doing some every few months or something like that with different topics. So we'll send a survey afterwards, or if you're on YouTube, we'll post this to YouTube later. We'll in the comments try to get feedback from what people are interested in doing. We can have more talks versus more panels, and the social mixer afterwards is another good way to have good interactions. So we look forward to hosting more of these and creating a real community within Tokyo for not just C++ but areas of interest as well. So thank you all for coming.
Thank you.
Thank you very much.
Thank you for hosting.
Thank you for hosting.
And thanks to our two panelists here as well. They happened to be in Tokyo, so they were kind of the excuse to get this started.
Awesome, and I just want to give a quick shout out to the unsung heroes of tonight, our amazing translators on the side. Thank you so much. I really appreciate it.